morning, students. In this lecture, I am going to discuss a very important topic, students, that is Newton's Cotes formula. Write down, students. Newton's Cotes formula. Newton's Cotes formula. By applying this, we get four formula, students. First one is trapezoidal rule. Second one is Simpson 1/3 rule, and Simpson 3/8 rule, and Weddell's rule, students. What, students? Weddell's rules. Now, the main purpose of this Newton course is we are evaluating a definite integral, students. What, students? We are evaluating a definite integral. Okay, students. For that, say let y is equal to f of x be any function, students. We are always finding y value at a particular point x. So for that we need, students, whenever given the integration, definite integration, we need always table values, students. What, students? Table values. Say the table values are here, x and y. So this is x0, x1, and so on, xn. Corresponding values are y0, y1, and so on, yn. Or, students, yn. Now I already told you, students, we are evaluating definite integrals. So we already known here for that Newton's forward interpolation. Or, students, Newton's forward interpolation. We are using this formula, students, to evaluate definite integration. So y is equal to f of x, that is equal to, what is formula, students? y0 plus p into del y0 plus p into p minus 1 into by 2 factorial into del square y0 plus and so on. Now what is p here, students? What is p? P is x minus x0 by h, students. P is x minus x0 by h. Now I want to write x, students, x. So how can you get x, students, here? ph, you transpose to the left hand side, students, plus x0. Now x is here, ph plus x0. Now suppose the integral form is integral x0 to xn f of x dx, students. F of x dx. That is equal to integral x0 xn, students. How can you get x1, students, here? x1 is you get x0 plus h. x2, students, x0 plus 2h. Now xn, students, x0 plus nh. How can you get xn, students? x0 plus nh. So this xn can be written as here x0 plus nh. Now f of x dx. Now I want to substitute here x is equal to, I want to put here x is equal to ph plus x0. Or, students, ph plus x0. Now I want to find dx value here, students. Dx value. So dx is equal to x0 is constant, so value is 0. h into dp. Now I want to find lower limit, students. Lower limit. So lower limit is x is equal to x0, students. So x is equal to x0 here. So x0, that is equal to ph plus x0. x0 cancel here. So that implies, what is lower limit here, students? P is equal to 0. Now upper limit. What, students? Upper limit. x is equal to, what students, x is equal to x naught plus nh, x naught plus nh, x naught plus nh. You substitute here students, x naught plus nh, that is equal to ph plus x naught. Again x naught cancel. Now that implies nh, that is equal to ph, hh cancel, that implies p is equal to n. Now what is lower limit students? 0. What is upper limit students? N. So this can be written as, that is equal to integral 0 to n f of, what is x students here? X naught plus ph into dx. Dx means h dp. Dx means h dp. So h is constant, so I want to write outside students, integration outside. So dp. That is equal to h into integral of 0 to n f of x naught plus ph students. See here students, x naught plus ph means x. So f of x. So I can write this one students, y naught. So write down students, y naught plus p del y naught plus p into p minus 1 by 2 factorial into del square y naught plus and so on into students dp, into dp. So that is equal to h into integral 0 to n y naught plus p into del y naught plus, multiply students here, 1 by 2 factorial means 2, p into p square minus 1 into p is p, so del square y naught plus and so on into dp. That is equal to h into bracket. Now you integrate with respect to p students. What students? You integrate with respect to p. So y naught is constant students. So y naught into, we get here p plus, we have p students. So get here p square by 2 into del y naught plus 1 by 2 into, or students 1 by 2 into integral of p square students. We get here p cube by 3 minus, what is integral of p students? Integral of p square by 2 into del square y naught plus and so on. What is lower limit students here? 0. What is upper limit? N. What is upper limit students? N. Now you substitute upper limit students at the place of p. So y naught, upper limit students n. So you get n plus p square students, n square by 2 into del y naught plus 1 by 2 into p cube, n cube by 3 minus p square students, n square by 2 into del square y naught plus and so on. When we substitute lower limit, what happens students? All the values are 0. Now, so this is called integral x naught x n f of x dx. This is called Newton's Cote's formula. What students? Newton's Cote's formula. This is general Newton Cote's formula. Okay students, once again students, let y is equal to f of x be any function. He given table values like this students. How can you get x1 students? X naught plus h, and xn x naught plus nh. Now to evaluate this integration, I am using Newton's forward interpolation. So what is Newton's forward interpolation? Y is equal to f of x, that is equal to y naught plus p into del y naught plus p into p minus 1 by 2 factorial into del square y naught plus and so on. What is p here students? X minus x naught by h. So I want to write x is equal to ph plus x naught. Now consider integral x naught to xn f of x dx students. X naught xn means here students x naught plus nh. So x naught plus nh f of x dx. Now take x is equal to ph plus x naught and dx is equal, we get h dp, and lower limit we get p is equal to 0 and upper limit p is equal to n. I am substituting here students and then applying here Newton's forward interpolation here, and you integrate with respect to p students, and then substitute upper limit, then you got Newton's Cote's formula students, Newton's Cote's formula. Initially I told you students, from this formula we get trapezoidal rule. What students? Trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, and Weddell's rule. And students, Weddell's rule. Now, if n is equal to 1 students, if n is equal to 1, n is equal to 1 means students, what is n is equal to 1 means here, we are taking up to here students. So that means here x naught, x1, y naught, y1, n is equal to 1 means. What is del y naught students? Del y naught. What is del y naught? y1 minus y naught. What is del square y naught students? Del square y naught, is there any del square y naught? So the value is 0. That means here it is I have to take up to here students. Up to here. So integral x naught to n is equal to 1 students, x1 f of x dx, that is equal to h into y naught, n value is 1 students, plus you can here also 1 value 1, so 1 square by 2, that means we get 1 by 2 into del y naught students, del y naught. Okay students, that is equal to h into y naught plus 1 by 2 into, what is del y naught students? Del y naught means y1 minus y naught, so y1 minus y naught, that is equal to, I want taking common 1 by 2 students, 1 by 2, that means we get here h by 2, so that we get here 2 y naught plus y naught, sorry, this is y1 students, y1 minus y naught, so this is y1 minus y naught, that is equal to h by 2 into 2 y naught minus y naught students, so y naught plus y1, y naught plus y1. Now I want to take here students integral x1 to x2 students, f of x dx. Come on, tell me students, h by 2 into y1 plus y2 and so on, integral xn minus 1 xn students, f of x dx. Come on, tell me students, h by 2 yn plus yn minus 1, Now integral x naught to xn students, integral x naught to xn students, x naught to xn, f of x dx, that is equal to h by 2. What is common factor students? H by 2. So h by 2 into, see students, y naught. Say y1 and y1 is here students. How many y1s are there? 2. Similarly, if I evaluate integral x2 to x3, we get there y2 plus y3. That means how many times we get y2? 2 times. Okay students, 2 times. And so on up to yn minus 1 we get 2 times students. And what about yn? We get 1. That means initial value and final value are 1 times and remaining all values are 2 times. So y naught plus yn plus 2 into rest of the terms students. What are the rest of the terms? y1 plus y2 plus and so on plus yn minus 1. This is called trapezoidal rule students. Trapezoidal rule. Now if n is equal to 2 students, if n is equal to 2, we get Simpson's 1/3 rule students. What students? Simpson's 1/3 rule. And n is equal to 3, Simpson's Simpson's 3 by 8th rule, students. 3 by 8th rule. And n is equal to 6, we get, students, Waddell's rule. What, students? Waddell's rules. Once again, students, if n is equal to 1, we get trapezoidal rule. If n is equal to 2, we get Simpson 1/3 rule. N is equal to 3, we get Simpson 3 by 8th rule. And n is equal to 6, we get Waddell's rule. Hope you understand, students. In the next class, I want to discuss the formulas of, once again, trapezoidal rule, Simpson 1/3 rule, Simpson 3 by 8th rule. Okay, students, enough, students. Thank you for watching this video. Jai Hind.